Now we move to the final presentation by Gerhard Hirzinger. Please, the floor is yours, Gerhard.
Yeah, thank you very much. And please excuse that I go a few levels lower now from where most of you are working, but maybe it's helpful a little bit for your work too. I called my talk, Compliant and Impedance Controlled Robots, a Paradigm Change. I was director of DRR, that is the German Aerospace Research Establishment, the Robotics and Mechatronics Center, and it became finally one of the biggest institutes for applied robotic research worldwide. And I have tried to push the idea of mechatronics forward in Germany and Bavaria, so the closest cooperation between mechanical, electronic, and computer science engineering for building intelligent machines of the future, where intelligence for us at the moment is much lower, of course. And as you can see here, we did a number of different things: space robotics as a main topic, industrial robotics, robot cars, airplanes, automatic control, medical robotics, and so on. Already in the early 80s, we saw that robots in the factory were behind fences. They had no sensing. They were stupid devices. And we tried already at this early stage to develop robots which collaborate with humans. So we developed force sensors and force balls where we could guide the robot and show how it should press against a contour. More natural programming. Important at that time was Neville Hogan in USA. I think he was the first one who defined the topic of impedance control, that is shaping a robot thus that it should react like an artificial mass, an artificial damping, and an artificial spring. And you can do this with a force sensor at the robot wrist, if you have such an arm, and you have just apply appropriate feedback. Most well-known became Whitney's resolved weight control, where you set mass and stiffness 0, and then you get a relation, a proportional relation between the force exerted and the velocity. So you can guide the robot around by taking it just at the force sensor. Nearly at that time, we tried to define a paradigm for future autonomous mechatronic systems. You start with the intelligent motion planning. It may come from a human, it may come from the machine itself by using sensory information, and then you generate from that a desired motion, but the motion is described as an acceleration profile, because acceleration is the mother of all physical motions. Not positions, not velocity, but acceleration. And then you will see inverse kinematics dynamics model as far as you know it. You get the nominal control commands, you put it to the system, to the real system, you have the system dynamics, you get the real motion, and you compare then the desired motion with the real motion, as you can see underneath. And there will always be differences, and you have learning control algorithms that generate the corrections to the commands, and on the other side, adapt permanently the model. This is a very general principle, usable for robots, for cars, for flying systems, for everything who is moving. And the first step then was to apply it to robot systems. So we said, okay, desired acceleration, we need the mass matrix, inverse dynamics and kinematics model, and then we need the torque control in the joints, because these are the real input commands we have. No position control, no velocity control, just a joint torque control. And a lot helped here Osama Khatib from Stanford University, who had the first ideas in this direction also, and we had many, many discussions and said these should be the robots of the future. And indeed, I think we were the first ones who could realize this principle when we saw that with a few lines of code you can generate completely different behavior. Robots are absolutely safe, they compensate gravity, and if you provide them with vision, then you have more or less human performance, tactile and vision control, and we made contests with children. For example, we have 2 tooth wheels which have 1 tooth difference, and the young guy cannot discriminate which is the right wheel, but he has now the idea it might be the wrong one, and the robot has seen it on the first glance. And but then the young guy becomes faster and faster, so he is superior then to the robot. But it's not. It's just an intermediary stage. I think next year at the Automatica in Munich, we want to show that the robot does these insertion tasks faster than any human can do. We want to make a competition on that. Okay, and then Daimler was Daimler was the first one who said, well, we need this cooperative robots without fences in our factory, and they assembled more than 1 million rear axle gearings with these cooperative robot systems. And
robots on a production
Ford
line
company
new.
was very
This
enthusiastic.
one's really special.
He said this is a new guy.
It's one of the first in the world to work hand in hand with assembly line staff at a car factory. The device is so clever it learns how to help you on the job thanks to high-tech sensors that can feel when you're standing next to it.
That was the license
programmed to do anything from make a coffee
which
to
Kuka
give you a
made.
head massage. At the moment,
They said you
it's
can also
used
do
by
massage.
workers to lift and
You
position
can
heavy
drink
parts
coffee with
on
us.
Fiestas.
It does everything like a
They've
real
only been
colleague.
installed at 2 workstations for a short time, but they're already part of the team.
Now this license product
More
of
than
Kuka
100 years after
was
Henry
really the
Ford
topic,
invented the
2
moving
years
production
ago at the
line,
Hanover
many
Fair,
robots
Merkel
aren't
and the
replacing
German
people.
Chancellor Obama
They're
didn't
helping them get more
nearly
jobs done
see nothing
faster
else.
and making it fun.
So it was, but everyone said this is very cheap, 80,000 euros or dollars. And then my young co-worker Sami Hadagun developed a version which is 8 times cheaper, about 10,000 euros or dollars. And he won the German Future Award 2 years ago. And since then there's a lot of emotion about these robots. The Japanese Premier Abe pointed it out when he came to the computer fair in Germany, and we have a lot of fun with that kind of robots. They are easily programmable. They are going now to the schools where young children are already programming them, and you see the idea here is a learning. Like a child, you test it again, you try it again, and finally the robot is able to insert the part, and then he tells it all the other robots worldwide. The knowledge is not separated, it's distributed worldwide. And there are many other robots, for example, they do different tasks, like opening a door with a key, and immediately they have learned also to insert this key, and they can do a different task with this knowledge of the one who has just done the pegging hole before. So this is shown next week also to the German Chancellor. She is very interested in these kind of things, and there's a big motion at the Technical University there. Of course, these robots address these kind of working places. Huge number of women, 80,000 for example, at Foxconn and other companies, who are doing the whole day nothing else than pressing buttons for our iPads and iPhones and so on. And you can discuss a lot whether this is useful to replace these working sites, but they will be replaced anyway. We developed also more complex systems like the triceps, biceps concept, where you have 2 actuators like in the human muscular system, but then you need a lot of motors. We had 55 in this arm, but we get low weight nevertheless and very elastic or compliant behavior. And you have typical, in the simplest version, you have 2 motors again, but one is changing the stiffness, one is doing the motion, and if you leave away the second motor, then you have the serial elastic joints, where the universal robot system, which is widespread, is using this concept. And the hammering like that, or this energy storage like in the right lower video, unfortunately it does not run now. Can you start it on the right? No. But drilling and so on, you need this kind of compliance, it's very important. Unfortunately, throwing the ball is very elegant, you cannot see it, because the video does not run. There is a lot of demonstrations how robots in the future should help humans, like preparing tea for elderly,
body control, and dexterity.
catching a ball. It's just skills which a robot should be able to do. One is throwing a ball, the other one is catching it. And on the upper side you can see that it's catching two balls simultaneously. Try it by yourself, or with your children, or with your grandchildren. It's not so
Despite the
simple.
challenges of vibrations, elasticities, distributed sensor.
People are very much interested in these kind of things. But the learning, of course, is very interesting. We made experiments. We had, I think, altogether 19 of these tubes with different surfaces. The robot has simple tactile sensors in the fingers. He can test them by just touching them and moving them around. Then we close his eyes. It's just more a gag because we just can switch off the vision system.
That should be
and
paper.
indeed, the success of the robot was higher than all of our co-workers in the institute. So he was better in discriminating the materials than all our co-workers in our institute. And of course, nevertheless, with artificial intelligence and so teleoperation, telecontrol with haptic feedback, we are talking about the tactile internet is important. We have shown that we can repair a pipeline or an oil platform in Korea. The delays of the fast internet are only half a second, and up to this half a second we can compensate the tactile delays. So can make things much easier. And that was interesting that the Russian cosmonaut on the space station, he had a joystick, a force-reflecting joystick. He controlled the one arm of our Justin, and on the left side down you see his wife in our laboratory, and she felt his pressure, and she pressed against his arm. He was half a year already on the space station, and she started crying. So it was so emotional for her. I did not expect that. And from that experiment it became clear that we can now shake the hand of our grandfather in Australia and whatever place in the world. And this is one of the interesting impacts. And then the most popular astronaut in Germany, Alexander Gerst, did these experiments from the space station down to our lab. He had some training, not much, and our co-workers made a joke. They let it smoke, and he was surprised and said, what happened here? It's smoking. And our colleagues said, oh, please take out the box and do another box in that. There might be a big fire. And he did it without training. And so the idea is that later on astronauts are circulating around Mars and first move or send robots down to Mars surface and let them build up habitats and so on, not land at the first stage, because return from Mars is very difficult. Now, mobility concepts go further. Legs are important, and to be honest here, we are not the champions in many areas. We are really far ahead, but concerning multi-leg systems, Boston Dynamics is the champion, and nevertheless we have beautiful mobile robots in Europe, in France, now, and Pepper. Also, a lot of people think Pepper is useful for elderly care. It cannot help so much here. On the right side you see the Italian development, the IIT's Cup humanoid or so. But the champion is Boston Dynamics. care using electrohydraulic systems. On the top right, this dog, this Pet Mini, uses our motors, a pure electrical system. So for us the question is, can electrical systems be really as naturally compliant as these electrohydraulic systems? But I think Boston Dynamics is really the leader here. Now, we have a big initiative in Bavaria now, pushing forward assistive robots on one side to production assistance in factories, and on the other side to healthcare and the social robotics area, helping elderly people stay longer in their homes, rehabilitation, prosthesis, new robotics. You all know that in most of the big hospitals, operations are made by robotic systems. The Da Vinci robot is a big success, transfers the motion of hands into the interior of the body, and many clinicals operate only with these robots. We had developed a much smaller system, but we did not find a company in Germany that dared to take up the fight against the Da Vinci system. And now Medtronic is a big American company. They are having the system in license. We will see how it will turn out, but my big hope was always the operation on the beating heart. Everything is available now. You can automatically servo the robot systems so that the surgeon sees apparently a system in rest, and so on. And next steps are tactile feedback and automatically binding knots and threads and so on. The topic that interests me most at the moment, and I started a big initiative in Bavaria with a school of geriatronics in Garmisch-Partenkirchen, which is a ski resort, as you may know, but has an overreaching society. And the idea is here to have two-arm robot assistants, which make the communication with children and relatives much, much easier, which prepare simple meals. It must not be complete, complex cooking, simple meals, which processes the vital data and only calls the hospital if there is a danger. Old people are no longer necessarily sent into an old people's home if they do not want to. And ordering meals from the supermarket or from the grocery using what we call an automatic small vehicle, like a bicycle, and you just order milk or whatever, and this is sent to you. So a lot of help. All the things are basically available. We just have to do them now. And the relatives can control the robot, for example, if it doesn't succeed in lifting up glasses, or if a more complex problem occurs, then the control center, which will be in Garmisch-Partenkirchen, there are experienced controllers now with force feedback. They can also help.
Guten Tag.
And
Herr Doktor.
the robots can shave people, as you can see, this kind of, they can do ultrasound.
Jetzt kriegst du einen Kontrast.
I will not show it too long. And on the other side, rehabilitation is such a big topic for robotics. The physiotherapists come only once, half an hour per day, and the robotic system should do the rest. We are just now introducing in the hospitals this kind of early mobilization, where again the physiotherapist does the motions once, and then the patient can by himself start moving his legs, and he can also make the bed in an upright position so that the blood goes into the legs. So a lot of means to let people earlier stand up again. They're lying too long in their beds without motion. Because just in the hospitals in the next weeks, so it's interesting. And of course, interesting are also the, unfortunately, the video does not run now. This is one of the most interesting videos. Can you start the video? This experiments in USA, in the Brown University. We were not allowed to do it here. It's 80 contacts to the cortex, and after 20 minutes of training, this lady, which is since 15 years paralyzed from the neck on, she was able to drink by herself. That was one of the most amazing and one of the most satisfying experiments in my professional life. And you can see her face and how happy she is. And this is, in my opinion, the future. As I said, we are not allowed to do this in Germany at the moment, but we are using other interfaces, electromyography, signals. Again,
can use this kind of interface.
But this patient
Similar
also,
to a joystick,
just by her
they can move the
remaining
robotic
muscular
arm up and
activities,
down,
can control the
left
arm.
and right,
And of course, we
and
need
back and
shared
forth.
autonomy in the future, so that the robot is near to something he grasps automatically.
As with the brain
The
gate
patient does
interface,
not need to do
EMG-based
any
commands allow
small
a
thing
person
by
to
herself.
perform simple.
Okay, yeah, and so we are many experiments with wheelchairs, where the wheelchair by the visual system positions itself so that it really can get through the door and then opens the door and so. And on the upside, there's a remote controller and tells the robot open the layer, and there's a medicine inside that to take this medicine out. And many assistance systems. In Japan, there are exoskeletons which are coming, which help workers in the factory to become stronger. But for me, the real dream is to make people run again, which are paraplegic, which stand up from their wheelchairs. If we succeed with that, then robotics is the topic technology for everyone in the world. Many thanks for your attention.